Grafana allows you to visualize some fancy stuff with your database. Now, you can use the Grafana UI to monitor what is going on in your RavenDB database cluster. You can create your own dashboard based on the metrics you choose to determine if everything inside your database is working the way you want it. There's a lot you can keep an eye on with RavenDB's Grafana plugin. You can track tags to distinguish which node you are tracking, like the URL of the server, the node tag, or the cluster ID. There are tons of fields like CPU usage, I/O weight, processor count, total databases in use. You can track information by server, database, collections, even by index. This enables you to boost performance without having to spend money. Simply identify bottlenecks in the system and target your fixes. You also get effective crash detection. If there are some ominous clouds brewing in your database, you will see them before the storm. Attack problems before they attack your users with an added layer of early warning. Keep your memory usage in safe zones, acting quickly before the needles touch red. Today, Senior RavenDB Database Developer Marcin Lewandowski shows you how to install and use RavenDB's newest Grafana plugin to keep your data running as smoothly as possible at all times. Feel free to ask questions by clicking the QA button at the bottom of your screen, and Marcin will be happy to answer them throughout the session. Enjoy your presentation, and here's Marcin.
Hello. Welcome in today's webinar about monitoring RavenDB with Grafana. What will be covered today? We will start with the solution architecture. Then we talk what kind of metrics we can collect using RavenDB via Grafana. Then we talk about the configuration, and then, like David said, we'll go through the live demonstration where we show step by step how to set it up, and questions at the end. Okay, solution to monitor RavenDB is built on top of the Telegraph, and Telegraph is a tool that allows user to monitor many applications and fetch data from them. In our case, it will be RavenDB, which acts as a source. It's also called input plugin for Telegraph. And once we collect such metrics in a Telegraph, we can output them to different kind of outputs like InfluxDB, Kafka, Elasticsearch, Graphite, SQL, and many more. So Telegraph abstracts the metrics. He can collect data from multiple sources, various sources, and output them to multiple outputs. In today's webinar, I would like to focus on the following deployment scenario. We will have 3 nodes cluster of RavenDB. We will use Telegraph to reading this data from those instances. And the Telegraph acts only as an agent for scrapping and storing this data. We set InfluxDB, which is time series database, to hold our information and about the history that we collect of the monitoring. Then at the end, we use Grafana UI to query information stored previously in the InfluxDB to see how our system behaves. Okay, like I said, we will use Telegraph for getting this data, but in general, this solution is implemented using REST API and JSON format. And what Telegraph is doing, he accesses 4 predefined endpoints that expose information about different metrics. In this example, we can see information about the server. And Telegraph asks about this data from time to time. By default, it's every 10 seconds, and it's stored. So in this solution, we have great flexibility that not only Telegraph can read that information, you can even build your own solution based on that. And you have full information what kind of metrics we expose in those endpoints. Also, to avoid Okay, so there are 4 endpoints available. We have general information about the server, about the databases, indexes, and collections. And since when we monitor collections, there might be many of them. So in order to reduce the load required, we allow to filter by database name, which reduce the system load. Okay, now let's quickly talk about what you can monitor on the server level. For sure, we can monitor uptime, CPU usage. This is also process and machine usage. Also, it's worth to mention that Telegraph comes with the built-in agent for monitoring machines that I will show you in a minute. But we also directly expose information about the RavenDB process, so you don't have to worry what's the PID of a process and so on. We have also metrics about the memory usage, disk information, how much the system storage is allocated on the disk, what's the free space, about the license expiration type, max scores, about the network, active connections, total requests, some metrics related to the how many requests our server have. Also about the certificates, we can monitor how much time left for certificate notification using some UI. We can also set alerts. So when certificate is about to expire, we can issue an alert, send some email or Slack message to be notified and prepared for that. And also we have some cluster metrics. At the database level, we of course expose database for which metrics it is, uptime, when the backup was, when there was last backup time, statistics about those other generic statistics about document attachments, how many alerts or performance hints we have, about this indexes. Of course, as you know, there is also per index stats, but here we have some basic indexing information because, like I said, this is generic and it's easier to get such statistics. If we want to monitor more detailed information, we need to use more sophisticated endpoint. And we have storage size. We can also monitor over time how much data is allocated by the data indexes and so on. About the indexes, we can monitor name, priority, state, amount of errors, how many entries we have in given index, and indexing speed. Of course, in order to determine which index is it, inside which database is it, we also include information about the server, about the database name, and the index, which allows us to filtering data. And the last thing, the last group of things that we can monitor are the collections. In the collections, of course, we also have information about the server, database, the collection name, and for every item, we have documents count, and we can monitor size of documents, revision, timestamp, and total size. So those are the things that we can collect. Full list is always available in the Influx plugin documentation, so it's easy to look up and check what else we can do. Okay. For Telegraph, we will need version 1.18 or higher, because that's the first version where RavenDB input plugin were introduced. And in order to fetch data from RavenDB, we need to configure them. I will show you the exact details during the live demo. Here, like I said, we have option to say which endpoints, which of those 4 endpoints we want to monitor. Of course, if we want many data, I can see that there is some question. We have Prometheus Okay, there is a question. We have Prometheus Grafana setup. This is the most popular setup by far. How to handle monitoring in such case? SNMP exporter, RavenDB exporter. It can be done using both of them. It actually depends on the usage, because we expose those monitoring endpoints. Plus, there is an option to use SNMP to monitor, and of course, even the telegraph can be pointed to the RavenDB instance, and using that configuration, we can also scrap data. So those two cases are possible, and we can use any of them to monitor RavenDB. And most of the things that we expose are available in SNMP that we expose in the RavenDB and in the monitoring endpoints. So there are more or less two similar things to achieve the same thing, but of course each of them has pros and cons. For instance, when we monitor using endpoints, as you can see in this example, using one hit, we can get a lot of data. So it's more efficient to gather such information with less calls. Okay. Now let's go to the live demo. So let's start with a influx and telegraph. I will expand those two things. Okay, let's start influx. Okay, this is InfluxDB 2.1.1, which means we don't need chronograph right now. The Influx exposes its UI using browser. Okay, so we need to set up. 1 second, let me type. In general, okay, when we have new installation, we need to specify username and password. Okay, now I think it's fine. Can click continue. Okay, so we have our InfluxDB running locally. Now let's try to. Okay, under data, we have sources, and one of the sources is RavenDB. And this input plugin allows us to monitor using official plugin. So the configuration is way easier than SNMP. And we can simply say what's here. And here you have information about what metrics we expose under server, under databases, indexes, and collections. So here you have the documentation, what can be monitored. Okay, now let's connect our InfluxDB with Telegraph. By default, we can use Telegraph agent for monitoring machine and many other things. Okay, we have it. Let's now, okay, using the latest InfluxDB version, Telegraph can be configured using URL, and authentication is done using environmental variable. So we don't have to configure every Telegraph agent via the files. Right now, it's centralized way, and everything can be configured inside InfluxDB. Okay, so let me write simple script that will okay. So first thing, we need to expose this influx token. Since I'm using PowerShell, I need to change the syntax a little bit, and then we will be running telegraph.exe, and config will be under this URL. Let's give a try. Okay, so Telegraph is connecting to the InfluxDB using this URL and gets configuration. Right now, we are running using default configuration, and this allows us to monitor system, let's say CPU, disk, and disk I/O. So if we go right now to explore data, and we will want to plot some data, we have it. Okay, now let's configure Telegraph to monitor RavenDB. We have a live instance, and I will start with, this is the publicly available RavenDB instance. Let's configure Telegraph to monitor this instance. So like I said, here you have information how to do that. This is the URL, and this is configuration. We can grab that, go to the Telegraph, and then here we add another section. Since our server is not secured, I omit that part. Here we have stats to include. If we uncomment that, we can fine-tune that. By default, we monitor all 4 things. Okay, so let's now replace the URL for our live instance. Let's save changes. Okay, and now I will restart Telegraph, and let's see if we manage to configure that. So as you can see, you can very easily point to the RavenDB server, and data will be collected for you. Okay, this is what we have. We have RavenDB server. Let's say we want to see the process usage, and right now we can see the usage, the process usage. Okay, what if we have more items to monitor? I also have running local cluster of RavenDB, which consists of 3 nodes. When I want to monitor that as well, I can again go to the Telegraph configuration. I can duplicate this section because each section is one input, is one RavenDB instance. So this will be first one. The second will, okay. This is second one and third one. So right now we'll set up monitoring of 4 RavenDB servers. Let's save changes. Okay, and now let's restart Telegraph. Okay, so at this point, we managed to configure from scratch InfluxDB and Telegraph to scrap data from those 4 servers. Now, so it means we have our data stored inside the database. Now, let's proceed with the Grafana installation. So I'm getting the fresh Grafana running server. And Grafana by default listens on 300 port. The default username and password is admin. I will not be changing this right now. Okay. Once we have Grafana running and InfluxDB running, we need to point Grafana to InfluxDB. And since InfluxDB is changing its query language from InfluxQL to Flux in version 2.0. There is one extra step required, which called mapping of the schemas when we collect using InfluxQL query language, which has one huge advantage. It has nice looking query editor, which I will show in a second. So before we can proceed, we need to configure such mapping. In order to map database and bucket, we need RavenDB client. Okay, let me PowerShell. I have, okay, that's the command that we will have to issue, and we will need a few things from our InfluxDB. The first thing is called organization ID. And I specified here. We'll also need API token. I will create the API token with full access for now. So this is the API token. So our InfluxDB client can see, can connect and authenticate to Telegraph. Okay, next thing is database, which is Telegraph. And we'll need the bucket ID. So let's find our bucket. And here is our bucket ID. Okay, so let's run this command. Okay, so we create mapping, which is only required if you want to use InfluxQL and you want to use InfluxDB in version 2.0 and or newer. And so this bucket is mapped to the database called Telegraph. So from the client, from the Grafana perspective, it will connect to the database, not the bucket. Okay, so let's now go to the Grafana and specify data source. The data source will be InfluxDB, and like I said, since this is we want to use InfluxQL, we had to define mapping. Now I specify the URL for the server, and the authentication is done using headers. So since here you will not see what I'm entering, I will do that here. We need to specify out token again, so Grafana can authorize. Okay, here we specify the database name, which is Telegraph, and it comes from here, database. So the bucket that we have in the Influx is mapped to the database called Telegraph with retention policy. Okay, let's try to test that. Looks like we have it. Okay, so we can go and create new panel. Data source is InfluxDB. We can choose measurement. Let's say, okay, this is the server URL. I have my local cluster and the public instance. So let's exclude public one and only use my local machine. And let's say we want to monitor CPU process usage, and we have data. About the field, we can use some values, and we also should group this data by, let's say, node tag. So we have our cluster has 3 nodes, A, B, and C, and in Grafana we can see that. Okay, so right now, let me go to the indexes. I will try to clone that index and deploy that in the feature using a feature called rolling index deployment. This feature allows us to deploy one node at a time. So let's do that. Right now, he deploys this index one node at a time. It starts with a B. So if we configure everything correctly, we should be able to see that node B is right now performing some operations. We can see that node B finished processing that. Right, C was finished and A is running right now some operation. So when our indexing is completed, one node at a time sequentially, if I refresh, I can see that first B was doing the computation, then C, and at the end, node A. So as you can see, it's chart for, let's say, CPU usage per every node. Okay, what kind of problems we can solve using Grafana and storing this information in Flux? In the RavenDB, we have something called cluster dashboard. But cluster dashboard doesn't show us the historical values because storing that is an additional effort, and not everyone wants that to store that by default. So if you want to monitor your instance, you can configure Telegraph input plugin and store, for instance, in InfluxDB, and later you can access this data. It can be used to compare the RavenDB, let's say CPU usage memory when you install new version of your application. So it's worth to mark given point in time using, for instance, annotation. We deploy to production. Let's say some version of your application, and when you have annotations over time, it allows you to see and correlate deployments with, for instance, changes in the memory, CPU, and document counts and other stuff. Also, looking at the charts allows us to see how swap behaves, what are the IO stats, how the collection grows, things like expiration of the certificates and other stuff that you want to monitor or correlate using that. So basically, that's it. If you have any questions, feel free to ask. Thank you so much.
Hey, Marcin, we have a question from Milos Ivanovsky. He asks, we have Prometheus, a Grafana setup. This is the most popular setup by far. How do you handle monitoring in that case? SNMP exporter or RavenDB exporter?
I already answered that question during the webinar. So like I said, we can use both. About the plans, there is another question about the official exporter for Prometheus. Not sure what it means, official exporter, because from what I understand, we can push this data to different sources. So if Milos can clarify question, that would be great. I can see on the chat another question. Is there any difference if RavenDB is hosted on Windows versus Linux? I'm afraid that this question is outside of the today's topic, and it's probably a broader question to answer. But in general, we support both platforms, and we have installations on both Linux, Windows, and this monitoring can be used on both platforms. That's for sure. Waiting for a bit for another questions. Okay, I can see some clarification. You need to write exporter in Golang. So every product has official exporter. It's easy to install and implement in Prometheus monitoring alerter. Not so. Like I said, from what I know, Telegraph has a lot of input-output plugins. Right here, we have input plugin that scrubs data from RavenDB. Not sure if this is some more direct way to do that. So. This is what I know, but for instance, RavenDB input plugin to Telegraph was also written in Go as an input plugin. Okay, I get that. So you don't have to use Telegraph. Probably here Telegraph is not database, it's just proxy, right? And output can be different. In today's webinar, we focus on the influx and Grafana, but I'm pretty sure that Telegraph can also write data from RavenDB monitoring endpoints directly to the Prometheus. Just like we have where's that here? Oh, sorry. Sorry, here. So InfluxDB is an example, but Telegraph if we search for output plugins, this is the version, the data formats and the plugins output data formats. So here are some output plugins, and about the Prometheus Telegraph format. Looks like this is some plugin for doing that. Okay, so I think I don't see any more questions. So thank you so much for today's webinar, and bye.